G'day everyone. Today, we will introduce our work titled Missing Value Imputation in Tabular Data Lakes. This research, which will be published in VLD-BJ 2026, explores how we can leverage the vast tables of data lakes to fill in the missing values in our datasets. So, why is this important? Well, incomplete data is a massive headache in data science. Imagine you're looking at a health dataset and you need to know the gender for John, who is 54 years old, but the cell is just marked as null. In many data lakes, we see an average of 38% of values missing. Simply leaving them blank isn't an option if we want accurate analysis. What we really need is a reliable imputed value to complete the picture. While there's been plenty of work on imputation, current methods often fall short when dealing with the sheer variety found in data lakes. They struggle to juggle different sources, like whether the value comes from the same table, a direct match elsewhere, or a similar value in another table, while also handling both numerical and categorical data across various file formats like HTML and CSV. That's where our method, SESID, comes in. It's designed to be a one-stop shop, combining estimation and search-based methods to tackle all three aspects of data variety simultaneously. To put it simply, our goal is straightforward. We take an incomplete table as our input, tap into the wealth of information within the tabular data lake, and produce a fully imputed table as our output. The core objective here is to effectively find a replacement for every single missing value, ensuring the final dataset is as complete and useful as possible. How do we actually achieve this? The big challenge is blending search-based and estimation-based techniques without losing the strengths of either. Our approach, SESID, uses a three-step process. First, we use contextual search to find candidate values by looking at the surrounding data. Second, we apply acquisition-guided estimation to generate values using influence functions and smart sampling. Finally, we use a classifier that looks at both table and column-level features to pick the most appropriate value for the job. We've put SESID to the test, and the results are quite impressive. For numerical data, our method reduces imputation error by an average of 16% compared to existing techniques. Even more striking is the performance on categorical values, where SESID improves imputation accuracy by a whopping 95% on average. These figures demonstrate that our hybrid approach is significantly more robust than traditional methods. In summary, we've introduced SESID, a hybrid method that brings together the best of estimation-based and search-based techniques for missing value imputation in data lakes. By handling data variety effectively, we provide a powerful imputation tool for cleaning up messy, real-world data.